Hello students, today we will be solving the IB Math A HL May 2025 paper 2 time zone 3 question number 9. You will be getting the solutions for the first 8 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve question 9. The maximum mark is 9. An airplane P is flying over horizontal ground at a constant height of 6 kilometers and traveling at a constant speed. It is approaching a runway AB, that this is the runway, which is 2 kilometers in length. Let G be the point on the ground directly below the airplane, where GA is x kilometers. The pilot's viewing angle of the runway is angle APB, which is theta. Okay, this is shown in the following diagram, and the diagram is not drawn to scale. Subpart A's question is show that theta equal to arctan of x plus 2 over 6 minus arctan of x over 6. And as soon as you see such an expression, many students will be getting confused. First of all, this arctan. Most of the students are not very familiar with using the inverse trigonometric ratios. And these two are getting subtracted, and so they will be getting confused. But you have to also see this one. This question is carrying just 2 marks. So this implies that the answer will not be that difficult. It will not be difficult. Okay. You have to realize that the arctan of whatever argument is given, the answer will be an angle. Because tan pi over 4 is equal to 1. Pi over 4 is an angle, and the 1 is the value of tan of this pi over 4 angle. So arctan of 1 is equal to pi over 4. So arctan of something, the result will be an angle. This is what you have to realize. As soon as you realize this, it becomes very easy. Let's see. So let us try to find out which angle is this and which angle is this. Okay. So x plus 2. Which one is x plus 2? This is GB. Okay. So GB is equal to x plus 2 kilometers. And which one is 6? It is PG or GP. Okay. So which angle or tan of which angle is x plus 2 over 6? X plus 2 over 6. This will be the opposite and this will be the adjacent. I'll be taking GB and GP. So I am taking this right angle triangle, the bigger one. Okay. So from the right angle triangle PGB, x plus 2 over x plus 6 is tan of this angle. What is this angle? This is GPB. So this is tan of angle GPB. Okay. Similarly, now it is x over 6. So now this time I'll be taking the smaller right triangle, that is GPA. Okay. So similarly, x over 6 is equal to tan of which angle? It is tan of angle GPA. Okay. And since angle GPB minus angle GPA is equal to theta, since angle GPB minus angle GPA is equal to theta, therefore theta will be equal to what? How do I write angle GPB? Angle GPB will be equal to arctan of x plus 2 over 6, okay? Or over here also I can write, therefore arctan of x plus 2 over 6 is equal to angle GPB, and this is arctan of x over 6 is equal to angle GPA, okay? So therefore theta is equal to arctan of x plus 2 over 6 minus arctan of x over 6, okay? Shown. When the viewing angle, that is theta, is 0.178 radians, the rate at which the viewing angle is changing, that means d theta dt, is 12.5 radians per hour. So part B's question is find the speed of the airplane. Okay, so that means speed will be what? Dx dt. Okay, the magnitude, of course, because it is the speed. So how do we get the dx dt? Then we can think of how to get the magnitude. Means not the magnitude, in fact it is the absolute value. I mean to say it is the absolute value, because speed, it will always be a positive number, okay? So but how do we relate this d theta dt with dx dt? We are having only this equation. We have to use this, otherwise we do not have any other option. I cannot at least see any other option over here. So let us try with this equation, okay? So first thing that I want to do is get rid of these arctans. Even I don't like like much these inverse trigonometric ratios. Of course, I'm a math teacher, I use these, but I try to get rid of them as soon as possible. So I will be taking the tan of both the sides, okay? Since theta is equal to arctan of x plus 2 over 6 minus arctan of x over 6. Therefore, tan theta is equal to tan of arctan x plus 2 over 6 minus arctan of x over 6. And now we will be using the tan A minus B formula. It is tan A. It is given in the formula booklet. A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Okay. So this is equal to tan of arctan of x plus 2 over 6 minus tan of arctan of x over 6 over 1 plus tan of arctan of x plus 2 over 6 times tan of arctan of x over 6. Okay, and tan of, and arctan, they are inverse functions, so therefore tan theta is equal to x plus 2 over 6 minus x over 6 over 1 plus x plus 2 over 6 times x over 6. Much more manageable, I think. So tan theta equal to x plus 2 minus x is 2, 2 over 6 is 1/3, so it is 1 over 3, and this part is, let me write one more step. It is 1 plus x square plus 2x over 36. Okay. So equal to 1 over 3, 1 over 36 plus x square plus 2x over 36. So therefore tan theta, 36 will be moving up to the numerator and 36 divided by 3 is 12. So this will be equal to 12 over 36 plus x square plus 2x. Okay. Now I have to get dx dt. I know theta and I know d theta dt. So what should I be doing? I'll be using the implicit differentiation technique. I'll be differentiating this equation with respect to time. So it is sec square theta d theta dt is equal to, I'll be using the quotient rule. So this one is u, and this one is, the whole thing is v. So first is u prime v, u prime will be 0. So the first term is 0 minus, it is u v prime. So I'm writing the u, and the derivative of this one. This will be 0. This is 2x and dx dt. And this one is plus 2 dx dt. Okay. Over 36 plus x square plus 2x whole square. Okay. Fine. Now I can, okay, let me simplify the numerator. I do not have to do anything to the denominator. This one is dx dt is common and 2 is also common. So let me take out the 2. 2 times 12 will be negative 24. There is the negative sign also. So negative 24 dx dt, and it will be x plus 1 over 36 plus x square plus 2x whole square. Okay. And we need the dx dt. So I have to make dx dt the subject of the equation. So therefore dx dt is equal to, then I can take, let me first of all get the value of dx dt. If it is minus, so I'll be taking the absolute value, it will be a plus sign. It will be a positive value. Okay. So, but first of all, let me get the answer. So sec square theta d theta dt times 36 plus x square plus 2x whole square over minus 24 x plus 1. Clear? But the problem is we know d theta dt's value. Let me just see what is it. It is 12.5 radians per hour. So d theta dt is equal to 12.5 radians per hour. And theta is equal to 0.178 radians. Theta is equal to 0.178 radians. Okay. So we have, since we know theta, we can get the value of sec square theta. And we know the value of d theta dt. But what about x? We do not know the value of x. We have to know the value of x. How do we know the value of x? Again, we come to this original equation, the only equation given to us to be shown. We will be taking the help of this equation, theta equal to arctan of x plus 2 over 6 minus arctan of x over 6. So theta equal to arctan of x plus 2 over 6 minus arctan of x over 6. And we know the value of theta, so we can find the value of x using our calculator, GDC, okay? So therefore, x will be equal to, approximately equal to, I'll be using the nsolve, so it is number 3 algebra and then number 1 numerical solve. Theta equal to, so 0.178 equal to arctan tan inverse and x plus 2 over 6, so x plus 2 over 6 minus arctan tan inverse x over 6, okay? And I come out of this and then it will be the comma and then x, and I can just, I do not know whether it will be having any negative value or not. Let me just, let me first of all press enter. Let me see what value of x does this give. Okay, it is giving a very good value, a positive number. 4.63047 I am taking. 4.63047. And it is in kilometers, of course. Okay. So now I have got the x value. Now I know everything. Okay. So, and I am seeing that x is needed over here, over here, over here. So let me save this value. This is the value of x that I have got. So let me save it. It is the distance. So let me save it as d. Okay. And now I will be finding the value of this part. So it is fine. First is sec square theta. Now, in TI Inspire CX2, you have the sec theta option over here. You can see this is the sec inverse, all these. But in case during the examination time this part is disabled, then you have to take 1 over cos square theta. Okay. So sec square theta, fine. You cannot input sec square, means this usually we write the 2 in between sec and theta, but when you are inputting in the calculator, you have to input it as sec theta whole square. Okay. So it is sec and theta is 0.178 and the calculator is set to radians. 0.178 and this is pressing yes. Okay, this is squared, fine, times d theta dt is 12.5 times this will be getting squared, so it is 36 plus I have saved that x as d, so it is d squared. See, the d has been bold. D has appeared in bold. Okay, so d squared plus 2 times d. Okay, and this will be getting squared. Fine, this whole thing is the numerator, and coming to the denominator, it is negative 24 times d plus 1 and enter. It is negative 424.88 I am writing. Okay, 424.88. So this is equal to negative 424.88, approximately equal to. So therefore, the speed of the airplane, right? Speed of the airplane, yes. The speed of the airplane, now I'll not be taking the negative sign because it is the speed. The speed of the airplane is equal to 425 kilometers per hour, correct to three significant figures. Okay. And so we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you like my explanation. And please subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We solve question 10 of the same paper. Till then, bye.